Okay, so I will briefly introduce the custom features I introduced to my engine. In this week, I basically made two very simple components. One is animator and another is the network component. And an animator is just used to easily simulate the animation of either players or something else to create things like moving animation, player movement animation, or just hit effect animation. So this component is also a C++ built-in component like rigid body and particle system, and all above is normal, and these are the things you need to specify. So sprite prefix is the prefix of the list of the sprites that you want to use for the animation. For example, I have a easy example here. Oh, sorry. So you can see here I have box 1, box 2, and box 3. These are the materials used again from the homework 8, the last test case. So I want 1, 2, 3 to be used for the animation. So in this one, for the sprite prefix, I will fill in the box, and frame count I will fill in 3 because there are 3 sprites. And frame duration means that how much frames will a single sprite stay. So if by default it will be 10, so every 10 frames it will change, and the loop will default to be true. So yeah, let's run this test case and try. So you can see that the ball changed its color. It's a easy animation, and there are only 2 frames. So yeah, that is basically the animation effect. And we can also see the template, player template. You can see here that the first 3 are the components written a given, and the fourth we add is the animator that we use a sprite prefix called circle. There are 2 frame count, and duration is 80 frames, and loop is by default true. And this is just the very common use of the animator. And what else can we do? I think we can we can change the sprite based on the moving character. We can have the walking animation or the jumping animation. Yeah, so you can see now we have a player figure now. So you can see when we are jumping, we have jump animation, and when we are walking, we have walk animation. And these are all bounded with the input. So when you input, you press the left button, then the animator component will be added, will be enabled from the player, and if you release that key, then the animator component will be enabled, and when you press the right key, it will be the same. So one advantage to have this animator is that when you are walking toward a wall, like so which one you cannot move. So usually we will make the animator to act just like every frame, or based on the speed, or based on the connection. So this one, we didn't have that connection. We just connect it with the input signal. So you can see that even if we cannot walk toward the wall, but our animation is still playing. So the watcher or the player will know that we are pressing the key. We are trying to walk into the wall. And we can also see the Lua script. This one, I think I override the keyboard control. Yeah, so you can see the keyboard control. We have 2 animator. One is for the left animation and one is for the right animation. So when we press the right, then you can see that the animator 1 is enabled, and on update on every frame on the start of the update, the animator will be set to be the false. So only if you are pressing this key, then the animator will be on and you can see the animation. So I think this is quite useful and easily used. And besides the walking and moving sprites of the player, and we can also make something like hit effect. So you can see to make the hit effect, we have two extra things you need to specify. One is destroy unfinished. It is by default false. So if you set it to be true, it means that this animator, when finished one loop of animation, it will destroy itself automatically. And if you want to have this animation to last for 3 or 4 times and even more times, then destroy itself, you can even further specify a thing called loops before destroy. This will work only when the destroy unfinished is true. Then, if you fill in like 2 times, then the animator will function for two cycles of the animation and die. So we can see the Lua script here. We have an animator controller. Yeah, you can see the animator controller. So we first delete this row. So you can see we on collision enter, this component is on the box we walk on and we touch. So we write the logic into the on collision enter, and if when the player contact, it will add animator here, and the destroy unfinished will be true. So it will only play for one cycle, we can see. So you can see the box under the player's foot has played one cycle of the animation, and it will stop itself. And this is nothing to do with the unenabled. It will totally destroy the animator component. And I think in this way, the memory can be saved and the logic can be further simplified. And then we can add this line, which means we want the loop to before destroy to be 3. Then the animator will play for 3 times, then kill itself. Yeah, you can see the animator plays longer than the previous one. It played for 3 times and then delete itself. And the effect is lasting itself, so you won't need to write any more logic like on collision stay or on collision exit or anything else. So this is just easily the animator component I write, and to let it function, your player or your anything else, you need to have either the rigid body or the transform, or the animator cannot just play the sprite on the location of the player. And the priority is rigid body is larger than the transform. So if you have either if you both have rigid body and transform, it will use the rigid body to consider the x and y. Okay, so then the another component I write is the very easy network component that called the network component. So this is also a built-in C++ class that serves like the other 3. And yeah, this is a bit complex. I use a header-only library called the ASIO. This one, the ASIO library, and it is specifically used for the client network user. So here on start, we initialize the TCP connection, and if this actor is a server, then it will wait for a client to connect. If it's a client, then it will connect to a server. So here you can see if it's a server, we will create a TCP listener on the specified port using the IPv4, and then create a socket that will accept an incoming connection. Then the server will be blocking. This is a blocking call that waits for a client to connect. And once connected, it will output some logic. And if this is a client, then it will create a socket and set up the server's address and port, and it will connect to the server. And if it works, and it will output something, and the connected will be true. And we use a try catch logic in all the on start and on updates to avoid some uncaught behaviors. And in the on update function, we can see that this will run every frame, and if it's the server, it will receive the coordinate and updates a target actor. And if it's the client, it will get its own coordinate and send themselves to the sender. So yeah, and this is just the early version. I just make it clear how to use it. So this one is not very easily used. You need to modify the initial scene and run it for 2 times. So yeah, the game config is the one you need to modify. And also, you can see here we have 2 scenes. One is called the client and one is called the server. Oh, sorry, I should open it in Visual Code. So you can see that the client scene, it has the transform as renderer keyboard control, because the client, we control the player in the client player, and the network component is server is false, and target actor key is the ghost player in the server scene, and the port is 1 2 3 4 5, the same as the server scene, and it has extra the server IP it will connect it to. And to make it running, we first need to run the server scene. So you can see the server is on and it is waiting for the connection on the port 1 2 3 4 5, which is we specified, and we changed the initial scene to be the client. And we need to add a run onto the, and you can see the client is connecting to the server at the specified server and the port we mentioned. So you can see there are now 2 windows here. One is server and one is client. The client is the one with the player, and the server is the one with the ball. So I will set to be the up and down to make it. So you can see in the in the client window, we have the keyboard control, and when we move the actor, you can see the one in the server also move. It will receive the location and change its own location. And you can see in the server one, we cannot move or change because it has no keyboard control. So this is only a very easy version of the network. And next week I will try further to make it a playable multiplayer game. Yeah, thank you. That's all.